Assalamualaikum warahmatullahi wabarakatuh. Congratulations everyone. Here we from the Department of Marine Science, Faculty of Mathematics and Natural Science. Was member are Helmi Ramadhan, Julizar, and Sella Purwasi. Are here we will explain the journal observation of momentary sea tides using GPS kinetic method written by Ahmad Fawais Safa dan Nirgulu Prapotomo and Muhammad Nur Cahyadi, Department of Geometric Engineering, Faculty of Civil Engineering and Planning, 10 November, Institute of Technology, ITS. Tide is a natural phenomenon that periodically fluctuates sea level is a result of the gravitational forces of the celestial bodies, especially the moon and sun. The influence of other astronomical objects can be ignored because the distance and size are relatively smaller than the moon and sun. Non-astronomical factors that affect the tide, especially in semi-closed water such as bay, are shoreline and topography of the water. Tidal observations are generally carried out at the edge of the beach or dock port by using the palm or other tide-going equipment. The tidal characteristic observed at the beach or pier port are generally only valid for access with a certain radius from the observation point. Outside the area, such as offshore, tidal characteristics are usually determined in the trade, namely by making prediction using altitude chart. This research was conducted with the aim of proving that observation of tides for the purpose of bathymetry surveys can be carried out using GPS observation kinematically on ship, so that practical purpose such as depth correction does not request direct on ship, so that for practical purpose such as depth correction does not request direct observation using tide palm. To be able to prove that compression data is needed in the form of tide observation data using tide palm or other tide gauge. With the comparison data, it is expected to be able to find out the difference between GPS data and observation of tide gauge. So, conclusion can be drawn from conclusion relative to the tide observation resolution the kinematic GPS on the ship.
In this study, there are other types of data to be processed, namely GPS type data, EGM 2008 data, and memory tidal observation data. In processing GPS observation data, the data generated at the time of observation is still in the form of original data generated by GPS receivers, so that the observation data must be converted into the receiver independent exchange format so that it can be processed on RTKLIB. In processing, the data needed is Rhinex-based and rover data. Additional data for processing Rhinex GPS is navigation information and satellite orbit. The result of processing the Rhinex GPS data is the latitude, longitude, and ellipsoid height of the GPS receiver on board. These coordinates are coordinates along the expression path. The next data processing process is processing the GM 2008 data. The result of processing the EGM 2008 data is the value of undulation at each coordinate point of the transmission line. The information needed to obtain the undulation value is the latitude and longitude coordinate generated from the processing of previous GPS Renex data. The software used is first version 2.0.9p. To run it using a script that has been provided by data provider EGM 2008. This undulation information is needed to reduce the high ellipsoid value procedure by GPS to arithmetic heights relative to the EGM 2008 GOID model. Determination of GPS the height is done relative to BGPS based using the MATLAB script. The MATLAB script is a program that contains GPS type calculation algorithm that will be run in MATLAB software. The height value of the ellipsoid base and rover which have been reduced or to arithmetic height and then look for different height value. The height difference value is then reduced by the height value of the base point against 0 tide second. This reduced value is used as the tidal value observed by GPS. In processing GPS tide data, the challenge is the amount of data generated. Tidal observation using GPS will produce data with observation interval reaching 100, or in the other word, every second will record data, while the tidal observation data for a moment, the phase observation interval is 5 minutes. In order to overcome this interval gap, the processing of refining and smoothing of data in GPS type data processing is needed.
Observation of text in the fisheries port of Sendang Biru, ex-Java, was carried out for today on 11 and 12 May 2017. They appear 131 to 132, with the duration of observation per day 8 to 9 hours of observation. The result of this study were in the form of a graph of text and a difference in height between the text of observation and GPS type. The floating result of text elevation show that the GPS type, graph pattern, and that observation are relatively the same. In figures 3.1 and 3.2 show blue points are GPS type ground patterns. GPS that elevation vary greatly because observation data is taken every 10 seconds. Black lines and dots show the result of plotting for test observation data. From the graphic picture, the GPS type ground pattern with the type of observation is relatively consistent. The residual from observation type data with GPS type show relatively small values. The residual value is the difference or individual difference in the tidal data population. The residual value calculated is the difference between the type of observation and the type of GPS and the type of the GPS filtering result. The residual values are shown in the table 1 below. In figure 3.5 and figure 3.6, show the that residual graph of the OY 151 and the OY 152. The green graph is a tidal residual graph of observation with GPS type, while the right graph is a that residual graph with GPS type smoothing. In table 2, The result of the calculation of the RMSI value will be shown. Based on table 2 above, GPS type RMSI values have a relatively small value, which range from 11 to 70 cm. In other words, the level of accuracy of the GPS type can be said to be high.